Let's start with year 1, chapter 1, algebraic expressions, and first section is 1.1, index laws. First one, we are going to discuss a to the power m, a to the power n. The base is same, and then we can simply add the powers, indices, m plus n. For example, a to the power 2 times a to the power 3. So we want to check the base is same. Yes, if the base is same, we can simply write 2 plus 3, that is a to the power 5. If I write differently this one, this is a times a, and this the multiplication a, another 3 a's I need to multiply together. So total 5 a's, a to the power 5. So instead of doing this one, so very simply we can simplify with this technique, with this law. The second one is a to the power m divided by a to the power n. We can simply write a to the power m minus n. A to the power 4 divided by a to the power 2. We can write a to the power 4 minus 2, that is a square. If I simplify differently, so there are 4 a's on numerator and there are 2 a's at denominator. So we can cancel out those two, then this is going to be a square. Now instead of doing this calculation, by applying this laws, we can simplify with a short time. Next law is a to the power m to the power n. We can write a m times n. If a to the power 3 to the power 2, we can write a to the power 3 times 2, which is a to the power 6. If I write differently this one, a to the power 3 times 2 mean a to the power 3 multiplied by a to the power 3, that is a to the power 3 plus 3, that is a to the power 6. Or 3a's multiplied by 3a's, so this is going to be a to the power 6. So this is lengthy. The simple technique is this one. We can multiply m and n together, and as extension I can express that a to the power m to the power n equal a to the power n to the power m. I can show this one. A to the power m to the power n, we can write like this: a to the power m n, and 2 times 3 is 3 times 2. P times q is q times p. Likewise, I can change a times m times n is I can write n times m. Then I'll bring this form: a to the power n to the power n. A to the power 2 3, I can write a 3 2. So this is the simple example. We need this kind of techniques for sometimes, like for example when we are solving 9 to the power 3 square root, or usually we will do 9 3 half. Now we can simply write this 9 3 half as 9 half 3. 9 to the power half 3. So this is square root 9 is 3. So 3 to the power 3. 3 to the power 3 is 27. So this is the use of this one. Next one is ab to the power n. We can write a n b n. So ab to the power 3 we can write a3 b3. A square b cubed to the power 3 we can write a 6 b9. What I did was I multiplied those two together. If I explain this one differently, this is a square 3 and b cube 3. So this is going to be a square is a 2 times 3 times b 3 times 3, that is a6 b9. So I can show differently this one again. B cube. So a square b cube multiplied by a square b cube multiplied by a square b cube. Now I can write this is 3 times a square multiplication and 3b cubes. So a2 plus 2 plus 2 b3 plus 3. So this is going to be a6 and b9. As extension for this one, a square b 3 times a square b 2. I can write this one a square b 3 plus 2, that is 5. Then this is going to be a10 b5. Since the terms are same, so I can add those two together. I can add the indices. So a square b, if I take a, it is clear that I can write this is a cube, and it is I can write that this is a square, then a 3 plus 2, that is a to the power 5. So we can turn back. What is a? A mean a square b to the power 5. So a10 b 5. So this is a different way of working. Same as a square b 4 and a square b 2. We can write a square b 4 minus 2, that is a square b square 2. So this is, we can simplify a4. So this is b1. So a4b square. You can see differently that a square b, if I take a, so this is going to be a4 over a square. a4 minus 2, that is a square. Now we'll see what is a. A is a square b. Now it is a square. So a4 b square. Now we'll discuss exercise 1a with the next video.